session, New Opportunities. I noticed that all the other sessions have apparel or textiles of one kind or another, spinning, fibres, dyeing and finishing. New Opportunities means that they don't really know where to put the subjects of our session, but I think that they've all been chosen for their intrinsic interest and their potential for taking things further. So I'm sure we are in for a stimulating afternoon. There is one change to the programme, and that is the last talk on privatisation by Ken Swanberg, and that one has been deleted, but Dr. Yi Li is going to give two presentations. There's the other presentation is in parallel 5, computational simulation of clothing and chemical behaviour with an improved particle model. So those two sessions from Dr. Yi Li. Now, just a few words of general requests. The mobile phones are a big distraction to speakers and to the rest of the audience. So I would request that, as a courtesy to everyone else, you turn off your mobile phones. We have a train company in the UK that has a special coach that is designated a quiet coach, where you don't use mobile phones, either going in or coming out. And I would request that this session be the equivalent of a quiet coach. And I'm sure that this will make it more enjoyable for all of us. And speakers, if we make sure that we speak to a microphone somewhere, so that we are able to be picked up by the translators and for the recording, and I'd be grateful if you observe the timescales. I'll give you a forewarning when there's a few minutes to finish. Let's move into the first session. I'm going to slightly rearrange the order. The first session is going to be presented by Dr. Yi Li. He has a graduate degree in textile science, and that was in the Northwest Institute of Textile Science and Technology. He did his PhD at Leeds University in the UK in 1988, and an MBA in Australia in 1996. He's now at the Institute of Textiles and Clothing, Hong Kong Polytechnic University. He has 190 scientific publications and patents. He's a fellow of the Textile Institute. He's a specialist in CAD applied to all areas of technology for fashion, and using computational skills in the area of simulation as well. He's responsible for many different research projects, and we're going to hear about two of them this afternoon. So, Dr. Yi Li, over to you, please.
Thank you very much, and thank you audience for your interest. This topic, which I have briefly said as a sensory engineering design of textiles and apparel. Initially, I put as a sensory functional design of thermal functional and mechanical functional design, which I found is a little narrow. So I will rephrase this in this paper. What I'm going to talk is that closing sensory and functional performance with a visual sensory engineering design, thermal sensory and mechanical sensory engineering design. Then that's the integrated sensory engineering design. The concept of what we call the sensory, because for textile and clothing, especially for clothes and fashion products, the focus is really how to satisfy consumers like you and me. And how do we judge our the garments? It's really up to our perceptions through different perceptions. One of the major things from the past to the current is the consumer consumption has changed dramatically from the formal wear in the 50s, 80s to currently become more and more informal and casual. And sportswear has played a very important part, not across different time scales vertically, in terms of across different countries. Also, there is a trend from an appearance and style towards comfort and sensory satisfaction, especially in the developed countries, which actually is validated and confirmed by a tremendous amount of consumer research and sensory research in USA, Australia, UK, and in Asian countries. The most important attributes required by consumers are comfort, fit, and style, which also we found similar patterns in China, which is fitness, comfort, and style considered to be the most important attributes by consumers. But what's comfort? How do we feel? Besides what we see here, and most importantly, the garments actually cover more than 90% of our body and stimulates various contact sensations. That's thermal, touch, and pain, the bendings under the skin. And psychologically, we have carried out this study more than many decades and identified three major dimensions of comfort. Like the color have three independent dimensions. That's thermal and moisture, pressure, and tactile. Because the consumers requires multi-sensory satisfaction from the body contact and from visual through the eyes and other senses. Therefore, we need to design the garments or fashion products to satisfy these sensations. So we first, most important certainly is the visual perception. So the visual perception is start from, like traditionally, we have 2D pattern, then we have a human model, which is the size of the body. Then we can identify, pull it together to design 3D garments. Then we will cover simulation to visualize the effects. So we just start from body measurements. The body measurements is giving important information about body size, about their size, the figure, and that is useful to generate digital models of the human body. That's a typical features of 3D design. We have the 2D pattern, which we multiply to get the facets of the pattern. Then we define the relationships between the patterns. Then find the human model, put it on the right place, and sew it together. Then we carried out analysis on the forces involved during that process between the arms and the interaction with the body. Then from this, what we can get is see the three dimensions, the fitness of the garments. Also, the draping effects of the can you turn down the light? Or be better effects. The draping effects of the garments. That's for fashion purpose. And from this also we can see the dynamic situation, how the body fits and what outlook And because of in the model simulation process, the fibers, properties of fibers, mechanics, everything which we can specify for the model. Therefore, we can carry out engineering design for the visual effects. Furthermore, we have the sensations from the body. We feel hot or cold, which is important. So we can carry out the analysis on the basis of the model. We have generated 3D garments together with the body. Then from this, we need to consider how the heat is generated inside the body and how sweat and moisture transfer from this. We will carry the analysis, visualize the temperature distributions and the comfort perceptions. As a typical model, which we need to consider the body as a core, will generate heat. And then on the skin, we have through blood flow transfer to the skin, then actually begin to also have the mechanisms of sweating, which give a thermophysiological mechanisms. Therefore, this will generate a three-dimensional model, pull it closer, become a thermophysiological model of a cursor. From this, we can then specify the properties of the fabrics from the fiber structure of the property and also structural features of the fabrics. And we carried out analysis on the basis of the models in the garments and in the interface with the body, like the moisture transfer, liquid transfer, heat transfer, liquid diffusion, condensation, sorption, radiation, all these different aspects. By solving all these equations using numerical methods, what we can get is a three-dimensional temperature distributions from inside of the body to outside of the environment, and how the sweat goes into the garments, as well as the temperature distributions on the skin surface, which determines how we feel, whether we're comfortable or not. And through this process, we can choose the fibers, how fine the fiber, what's the cross-section, what's the surface energy, and what's the yarn structure, and how the fabric structures will influence finally the garment structure, how much you cover, how many layers, and then what's the relatives. All this will affect the perceptions of thermal comfort. So we call thermal sensory engineering design. That's one example which we simulate athletes which is working from rest, start working for 20 minutes, they have a rest. Then we can see the temperature distributions from the body core, from the skin, and from the garments. And at different stages, how that change dynamically. If you change the fibers, change the construction of the garments, the distributions will change. Another aspect is the mechanical sensory perception, which is related to how we feel too much pressure, how stiff, so on and so on. So what we have is we get the 3D garments. Now we consider the body has a bone, tissue, and the skin. So we develop a mechanical model of the body. Then we carry out the body, how the garments contact the body, then carry the simulation and analyze the pressure distributions and the sensory comfort issues. That's a typical sort of garments you can design on the basis of digital model of the body. We can design the garments in 3D dimension, with the fitness specified in the garments. From this, we can carry out the analysis on the basis of the biomechanical model, bone, tissue, and skin, with the specify the mechanical properties of the of the human tissues and organs. And from this, you can specify the properties of the fibers, like wool, viscose, polyester, nitros, and so, and also the fabric mechanical properties and the multi-dimensional situation. We carried out solving equations which take into account the moment equation, transaction, displacement, content sort of boundary conditions. From this, what we get a dynamic pressure distributions during the wearing process. As one example, if you put a very tight garment, when the garment reaches the hip, you can see the high pressure in this area, which is uncomfortable. And also you can see the tight-fitting garments will change the deformation of the body, as well as the deformation of the garments itself. So that's all about different sensations of pressure comfort, visual satisfaction, and thermal comfort. So we need to consider all these different sensory requirements to make a design and develop products to satisfy the needs. That's called integrated design. Like mechanical for models for fashion design, and also that mechanical models for physical models, thermophysiological model for thermal comfort, as well as mechanical model for mechanical sensory comfort. For different products, it has a different requirements. Like this type of fashion, high fashion products is really dripping. Look at the dripping effects are important. The color effects are important. For this type of sportswear, the thermal comfort is very important. Mechanical comfort becomes very important to even enhance the performance of the athletes. For this one, the surface structure becomes important. That's fluid dynamics, which also become part of the engineering and design process. And we have carried out analysis, consumer study, for different garments for winter, spring, summer, or sportswear. The relative importance of different sensory factors are different, like a tactile, thermal, moisture, pressure, which has a different weights in terms of its contribution to overall satisfactions. Therefore, integrated sensory engineering design is essential to get the competitive edge in the modern consumer markets, including fashion, mechanical, and thermal. Thank you very much. Questions?
Thank you very much indeed.